this video, we're going to look at integrating even powers of secant x and odd powers of secant x. And you will see subtle differences between the two different approaches. So here we have integral secant to the fourth x dx. You will see immediately that secant to the fourth x is an even function. So our strategy is going to be to factor out secant squared x and apply a trig identity and a U substitution. So what we have is integral secant squared x times secant squared x dx. Now let's apply trig identity. Secant squared x is 1 plus tan squared x. And we save this factor, sec squared x dx, because U substitution will take care of that. Secant squared x dx. Now we're going to multiply secant squared x through and simplify this integrand. So we get integral secant squared x plus tan squared x secant squared x, all integrated with respect to x. Now let's split up the integrals. We get integral secant squared x dx plus integral tan squared x times secant squared x dx. We will apply the substitution technique to the second integral. So we're going to let u be equal to tangent x, and its derivative du will be equal to secant squared x dx. The first integral sec squared x dx, that's very easy because we know the antiderivative of secant squared x is just tangent x. We will do that on the next page. So here we have integral sec squared x dx plus integral tan squared x times sec squared x dx. The first integral secant squared x dx, this is just tangent x plus constant c. Now let's look at the second integral. We have integral tan squared x times secant squared x dx. We're going to apply U substitution. We'll let u be equal to tangent x, its derivative du is secant squared x dx. Let's label that. So tan squared x, this part of the integrand will be u squared, and sec squared x dx, this part will be du. So we have integral u squared times du. And reversing the power rule, that's going to give us u cubed divided by 3 plus c. Now let's put u back in, and we will get tan cubed x, because we have to get the answer in terms of x. Tan cubed x divided by 3 plus c. So let's now put everything together. This integral is going to be integral sec squared x, that's just tan x. And the second integral, we did U substitution, and we found that to be tan cubed x divided by 3 plus c. So the integral secant to the fourth x dx is found to be tangent x plus tan cubed x divided by 3 plus c. All right, let's look at another example. Here we have integral secant cubed x dx. You will notice that the power of secant x is odd. So the general strategy is always reduce odd power by 1. And in this case, we have to integrate by parts to solve this. So we have integral secant x times secant squared x dx. And we're going to integrate by parts. Choose u easy to differentiate. Choose dv easy to integrate. So you can clearly see that we're going to let u be secant x because that's easy to differentiate. Derivative of secant x is sec x tan x. And we'll let this part sec squared x dx be dv because that's easy to integrate. Integral of secant squared x is tangent x. All right, let's write that down. So we have u is equal to secant x. Its derivative du is equal to sec x tan x dx, and dv this part is sec squared x dx, and antiderivative of secant squared x is tangent x. All right, let's put this in a box. So the integration by parts formula is integral u dv is equal to uv minus integral v du. We're going to apply this formula. So integral sec x times secant squared x dx is going to be u times v. U is equal to secant x. V is equal to tan x. That's u times v. Minus integral v, which is tan x, times du, which is sec x, tan x, dx. We're going to simplify this a little bit. We get sec x tan x. And simplifying the integral, on the right, tan x times tan x is tan squared x, integral tan squared x, sec x, dx. It's important to note when you're doing integration by parts that the formula integrates this part already. So the only part that we need to process is this part, integral tan squared x times sec x dx. All right, so what we have is integral of secant cubed x dx is sec x tan x minus integral tan squared x times sec x dx. We're going to apply trigonometric identity. Tan squared x is equal to sec squared x minus 1. So we have integral secant cubed x dx is equal to sec x tan x minus integral sec squared x minus 1 times secant x dx. So now let's simplify the integral a little bit. So we have integral secant cubed x dx is equal to sec x tan x. Let's multiply the secant x through, so we get secant cubed x minus secant x, all integrated with respect to x. So now let's split up the integrals. So we have integral secant cubed x dx is equal to sec x tan x minus integral secant cubed x dx, and minus times minus will give us plus, plus integral sec x dx. Now we'll add integral secant cubed x to both sides. Notice the thing we're looking for, integral secant cubed x dx, reappears here. This is a recursive nature of this type of question. So bring it over and we get 2 integral secant cubed x dx is equal to sec x tan x plus, what is the antiderivative of secant x dx? Well, that's just going to be log of sec x plus tan x. It helps to memorize that. Plus constant c. And now we'll divide by 2 both sides. So divide by 2, divide by 2, and divide by 2. And what we get is integral of secant cubed x dx is 1/2 times factoring out the 1/2, 1/2 times sec x tan x plus log of absolute value of sec x plus tan x plus constant c. All right, thanks.